We're here again in the space station flight control room, all the activities going well, and as we've mentioned, the focus has been continuing to be on the HTV operations, which continued throughout the weekend, that actually resulting in the off day for the crew members, but it was done in large part due to a lot of different teams here on the ground team. Joining us here is Megan Levins, who is one of the robotics officers, but specifically the lead for Robot. Thanks for joining us. Why don't you start by, can you explain to us what Robot is?
Robot is our robotics onboard trainer. It's what our astronauts use in order to prepare for big robotic missions like HTV-4. So they use it as, it's kind of a simulation of what they'll actually be doing on the real day so they can practice in advance.
And this is a tool that they use from when they're assigned for the mission as well as on orbit?
Yes, it's the same simulation they use on the ground, so they spend all their time on the ground preparing for, like, say, HTV-4 or a SpaceX mission or an EVA using this same software, so when they get on board they can use what they're very used to and familiar to them and is of a high quality nature to prepare on board.
Can you tell us a little bit about the training curriculum for Robot and robotics in general? How does that, once an individual is selected as an astronaut, is that part of their astronaut candidate training? Is there a more advanced skill or training that only occurs once they're assigned to a mission?
They do a general training before they're assigned to a mission, that they get qualified to use the robotic manipulator, the Canadarm2. And then once they are assigned, they use simulations like Robot to prepare specifically for the mission that they have assigned. So our crews that are on board now used the sim to prepare for HTV-4. Once they got on orbit about 2 weeks out, since it may have been a long time since they've been on the ground, they used Robot as well as the Canadarm2 to prepare, kind of refresh their skills, remind them of what's really involved with HTV-4 so that they're very prepared when the time comes.
And some of our viewers may have heard about DUG in the past, which is also another term that's frequently used when robotics comes up. Can you explain to us the distinction between DUG and Robot?
DUG and Robot are similar. DUG is used more for situational awareness. It's more of a graphic tool. It shows the crew members the space station. They can put the Canadarm2, an EVA crew member, the HTV in places where they expect it to be and see what that looks like. Robot is a little more in-depth in that it actually simulates the entire robotics workstation. So they have hand controllers to actually fly the Canadarm2 around, go in for the capture, press that trigger to get the good capture, and then do whatever other operations they may have coming up.
How much proficiency training does a crew member usually need to prepare for these types of dynamic activities that we just had?
Well, in cases like HTV-4, our nominal plan, they do about 3 robot sessions and then 2 sessions with Canadarm2 where they actually go over and grapple, or at least go over the pin of a real grapple fixture flying from the cupola workstation itself.
And how long is the session?
About an hour, depending on the session. We'll do anything from watching the HTV approach so they can refresh on their HTV-specific telemetry, and then we'll go through and actually fly the robotic manipulator a couple times so they can get refamiliarize themselves with that operation as well. So anywhere from an hour to an hour and a half.
So Robot recently underwent some upgrades. Can you talk to us a little bit about that?
Yes. As you can imagine, something that's so graphic intensive like Robot, it does take a really long time for the simulation to even start, which is basically a person standing there watching a computer boot, which is not quite entertaining. Now, what we start with HTV-4 is we can actually do that part of the operation from the ground. So as soon as a crew member is ready to start their operation, they can walk right up to the robot workstation, and it's all set up and ready to go for them.
And I'm curious, it seems like this might have been something that could have been designed all along, but this was actually an upgrade done to specifically preserve some more crew time.
Yes, we're paving the way so they can do more science, better prepare for HTV, get the space station ready.
Do you have any sense of how much time that saves? Like, how much did that boot up take?
Basically, in the 2 weeks leading up to a free flyer, it saved over an hour and a half of time, which is a lot of crew time.
And so this was the first time that they've been able to use that?
Yes. And we'll be rolling this plan out for all other free flyers, so we'll get this crew time savings every time.
Sounds like a very valuable upgrade. You were also explaining to me that you're also an instructor, which is kind of unusual for flight controllers.
Yes, it's just my background started with instruction, which is how I'm so familiar with robots, since it is a crew training tool as well as a flight control tool. So it helps kind of segue into that nicely.
And can you tell us a little bit about your background that led you to NASA and being a robotics instructor?
I got my degree in physics from the University of Nevada, Reno, and I've always loved the space program and always knew I would end up here. And robotics is a very interesting field, so it was an easy transition. Started off as an instructor, training the crew members all the way back with increment 19, all the way up till now, and then started on the flight control side with actually executing ops from the mission control.
I would think having that instructor perspective would really help from being as being a flight controller as well, especially interfacing with the crew or knowing how they were trained and being able to kind of relate to them for real-time ops.
It does really help when the crew is involved to have a better understanding, or at least a really good understanding of how they're thinking, and especially if you've trained this particular crew, you're very familiar with their habits and what they like to do and how they operate. Each person is different, so it helps.
And there's an instructor assigned to each crew? Is that how it works?
Yes.
I would imagine, or it seems like I've even heard a little bit, robotics is some of the more challenging training that astronauts go through.
It is, and especially since it's not something you deal with every day, it has to come up periodically. It can be intense.
Can you tell us a little bit about what kind of skills are required, or what are the challenging aspects of it?
It's a lot of hand-eye coordination. Basically, you have at the robotics workstation, we have 2 hand controllers, and you have to operate these 2 hand controllers simultaneously to control a very large robotic arm out in free space and make sure you're watching all your clearances and looking at all your camera views and out your window. It takes a lot of brain power.
Yeah, and doing 2 hand controllers simultaneously seems
Yes.
like that would be hard. I know it would be challenging for me.
Yes, and especially with things like HTV4, you really do need both of them.
Gotcha. Well, thank you so much, Megan, for joining us and explaining to us some of the behind-the-scenes upgrades that are going on that have helped the crew and the ground control team be successful with these activities.
No problem. Thanks for having me.